Next problem. In cone, cylinder penetrates. So, a cone of base diameter 70 and axis height 65 mm is kept on HP on its base. It is penetrated by a horizontal cylinder of diameter 35 mm with its axis parallel to VP and intersecting the axis of the cone at a distance of 20 mm above the base of the cone. Draw the projection showing the curves of intersections. Problem number 58 from TechMax book. So in this problem, cone is penetrated by cylinder. So cone, as you know that cone, so here is a cone base diameter 70 and height 65 mm is kept on HP, and the cylinder of diameter 35 mm is intersecting the axis. The axis of the vertical cone is intersected by axis of horizontal cylinder at a distance of 20 mm above the base. Draw the projection showing the curves of intersection. As we know that first we will draw the top view, front view and side view of vertical solid. Here that is a cone. So cone top view will be circle, front view will be triangle. So circle of diameter 70 means radius 35. This radius 35. Radius 35, and this is the top view of cone. Then vertical solid is divided in 4 parts. I am giving this A, B, C, D. So this A, B, C, D and apex O. Front view of this cone is triangle. Base diameter is 70. So 35 right, 35 left. And axis is given to it, that is 65. Height of the cone is 65. So this A dash, this B dash, D dash and this C dash. And I am joining this cone like this. So this apex O. Similarly, side view. For side view 45 degree. And axis or center will be projected. So this axis diameter is 70 means 35 mm left side, 35 mm right side. So this 70 and height will be projected from front. So this height to this cone. So this D double dash, this will be A double dash, C double dash and this P double dash. And this apex should be joined by the end generator and this base. So this is the top view, front view and side view of cone, vertical cone. It is penetrated by horizontal cylinder of diameter 35. Axis of cylinder is intersecting the axis of the vertical cone at a distance of 20 mm from the base. So this 20 mm from the base, and diameter of the cylinder is 35 mm. So 35 mm means radius 17.5. This 17.5, and circle will be visible in side view. Cylinder axis is parallel to VP, so side view appears as a circle, front view rectangle, top view rectangle. Then divide this cylinder circle into number of equal parts, say 8. So one angle will be of 45 degree. So this one angle will be of 45. I am giving the number as 1 double dash, 2 double dash, 3 double dash, 4 double dash, 5 double dash, 6 double dash, 7 double dash, and 8 double dash. Project this cylinder in front view as well as in top view. So these are the generator of the cylinder, generator, and length is not given, so I am considering 100. So 50 mm right side and 50 mm left side of the axis of the vertical cone. So this cylinder and cone will be like this. Previously I have drawn front. Now make it dark, the part which is visible. So these are the generator 3, this 2 4, this 1 5, this 6 8, and this 7. Project it in front view, so length will be projected from front and width will be projected from side. So this cylinder, generator, okay, so cylinder will be like this. So this 5 number generator, this 4 and 6 number generator, this 3, 7 number generator, this 2, 8, and this 1. Okay. Now, in case of cone, if you imagine there will be two curves, intersection curve from the top and intersection curve from the front as well. So first we will draw intersection curve which is visible from the top, and to draw intersection curve there are two methods. One is cutting plane method and another is generator method. So we will follow cutting plane method because it will be easier than generator methods. So I am measuring this O axis of the cone, O7 intersecting the generator 7. So this O to this 7 and this 7. Okay, so I am giving the number this as a P1 and right hand side Q1. Then axis of the cone O68. So this O8 generator, cut the 8 generator on the right hand side, and 6 generator, 6 number generator. So this P6, this P8, this Q8, and this Q6. Then 1 5, O1 5. So this O1 this 1, this 5 and this 5. So this P1, Q1, P5 and this Q5. You are seeing from top. So this face of the cylinder is visible. So this curve will be made with the help of French curve with visible line. So join these points with the help of French curve with visible like this. Then axis or O24. So this O2 and this 2, this 4 and this 4. So this P2, P4, right hand side Q2, Q4, and last one axis 3. So this O3 and this O3. So this is P3 and this Q3. Join these points with the help of French curve with invisible line because this bottom surface is invisible. Okay. Now complete the cone visible, complete the cylinder visible up to visible, then invisible, then visible. This visible, invisible, and this. And this base of the cone will be invisible due to this cylinder. Due to cylinder this base is invisible. So this much will be invisible. Okay. Now front intersection curve. So again you are seeing from this side and this side. So we will start from the 5. So 5. Project this 5. This 5. Okay, then 5 will join to 4, 5 will join to 6. If you are doing left hand side, so P5 will join to P4, P5 will join to P6. So P5 and P6. So this 6 and this P4. P5 will join to P4. P4 is here actually. So this P4, okay, and this P6. So this P5, this P6 and this P4. And last P5, P6 will join to P7 and P4 will join to P3. So project this 3 here and 7 here. Join these points with the help of French curve and this curve is visible. Then P7 will join to P8, P3 will join to P2. So P8 here overlapping because axes are intersecting. P3 will join to P2. This will overlap by P4 and last P1 will overlap by P5. Similarly on the right hand side, so we will start from the Q5 will join to Q4 and Q5 will join to Q6. So this 6 and last 7. So join these points with the help of French curve line. Now cylinder invisible because it is inside the cone and this cylinder is inside the cone. Finally give the dimensions and symbol. So draw this figure on your sketchbook and show me. For next lecture we will start the production drawing, assembly details, etc. etc. So these 2 chapters, development of surfaces and intersection of solids, we have completed. Now we will start assembly drawings or conventional representations or what the symbols and conventions are used in machine.